sometimes you have to back. Oh, that looks not much better.
Anybody wants to hand in quiz 4, you're welcome. And the sooner you hand in, the better for me. Sorry guys, sorry. Guys, could you listen please? Question 1, the question is to find the quantile at 0.1, 0.25, 0.5, 0.75 and 0.9. So let's start with say 0.1. You remember the formula I gave you in the lectures, guys. So in this case your P is 0.1, your N is 25. So N plus 1 times P is what? It's 2.6, right? and the integer part of that is 2. So your Q, if you use the formula I gave you guys in the lectures, this will be x2, alright? That's the second smallest data point. 2.6 minus 2 multiplied by x3 minus x2, right? This is the formula I gave you guys. You should remember from the notes I gave you in the lectures. This is the formula. So this would be, if you work this out, the second smallest data point is 0.229. 2.6 minus 2 is 0.6, and the third smallest data point is 0 point, I mean 0.639. Do you guys follow what I'm doing? Yes? Alright, if you work this out, you get 0.475. So that's the answer. That's the quantile at 0.1. The next one is the quantile at 0.25. So to find the quantile at 0.25, your P is 0.25, your N is 25, so N plus 1 times P would be 6.5. The integer part of it is 6. So therefore Q hat at 0.25 will be the sixth smallest data point. 6.5 minus 6 multiplied by the seventh smallest data point minus the sixth. Right? Sorry guys. So if you work this out, you will get, the answer will be 2.1065. Alright guys, are you with me or not? And the next one is the median, which is Q hat at 0.5. So your P is 0.5. N plus 1 times P is 13. The integer part is also 13. Right? Okay, so your Q hat at 0.5 will be x13, the 13th smallest data point, plus 13 minus 13, x14 minus x13. So this whole thing is 0. So the 13th smallest data point is 2. If you read it from the data that is given to you, you will see this is 8957. And similarly, you can do the others by yourself. So can you now move on to question 2, please? So this is, it's mechanical. There's nothing to it, right? Just using the formula and plugging the numbers in. So there's nothing. Can you guys move to question 2, please, now? Any you guys okay with that or no? Okay. Question 2 now.
That's the part that I got to as well. Isn't the sample different? Why would you tell us to calculate in the first and the second? Okay, anyway, let's do the median. You do 20 and 1, right? And then divide by 2. Is this one? Sorry. Then you just add, okay, what's the n divided by 2? So that'll be 20 divided by 2 plus 10 and 11, and then you just add them and calculate.
Alright, have you guys done question 2? The 5-number summary means the minimum, the first quartile, median, third quartile, and the maximum. Those are the 5 numbers. Okay. The minimum, first quartile, median, third quartile, and the maximum. Alright, let's see how we can do this. Question 2, part 1. Alright, we want the 5-number sum. So the minimum is the smallest data point, which is what? Is 29.14. Alright, and the second is the first quartile. Remember, the first quartile is Q at 0.25, right? So to work this out, your P is 0.25. Your N is already given, which is 20, right? So N plus 1 times P is 5.25, and the integer part of it is 5. So therefore Q okay, this is the first quartile, right? And if you work this out, you will get the answer 37.0325. And the next one you need to work out is the median, which is Q hat at 0.5. So your P is 0.5, your N is 20, so your N plus 1 times P will be what? Will be 10.5, right? And the integer part of that is 10, right? So Q hat at 0.5 is X, the 10th smallest data point, plus 10.5 minus 10 multiplied by X 11 X 10, right? And if you work this out, you will get the answer 41.186. So that's the median. And the next one is the third quartile. The third quartile is Q at 0.75. So your P is 0.75, your N is 20, N plus 1 times P will be what? Will be 15.75, right? And the integer part of it is 15. So the third quartile is X 15, 15.75 minus 15, X 16, X 15, right? And if you simplify this, guys, you will get the third quartile to be equal to 44.01975. And finally, the last number of the summary is the largest data point, which is what, 50 51.261. So this is how. So if somebody asks you to give a 5-number summary, this is what you need to do, right? You need to compute these 5 things, right? The second part of the question is to calculate the sample mean and the standard deviation. Right. So this is part 2. Part 2 of question 2. Sample mean is sum of all the numbers divided by 20, which is going to be, so it's going to be, the first number is 29.14 up to 51.261. So you sum all these numbers and divide by the number of data points, which is 20, right? And if you do that, you will get the sample mean, which is equal to 40.6942. All right, this is the sample mean. And then the sample standard deviation. Remember the formula for the sample variance, which I've corrected in the lectures, is like this. This is the formula for the sample standard deviation, and the formula for the this is the formula for the sample variance. So this is sample variance, and the formula for the sample standard deviation is simply the square root. Are you guys okay? Yes, okay. The formula for the standard deviation, sample standard deviation is this one. This is the formula for the sample standard deviation. And you should plug in all the numbers, and you have to do this by a calculator, obviously. You can't do this by hand. So if you plug in all the numbers, you will get the following answer. Alright, this is what you will get. I'm sure most calculators have functions for computing the sample mean and the sample standard deviation. I have no idea how to use them, but I'm sure you do. So anyway, so that's part 2. Are you okay, guys? You're right, sir? Yeah.
Well, there is n minus 1.
It's n minus 1. This is just a formula, sir. It has n minus 1, not n. I think I corrected that in the lectures. I mean, 2 or 3 weeks ago, I had written it as n, but it should be n minus 1. Yes?
That answer you got the variance.
Sorry?
That answer you got there, the variance.
Oh, it's the variance, is it? Oh, okay. So it's just the square root of it. Just take the square root of it. Okay. So the variance, so it's just whatever the square root of that number is. Yeah. Any other questions, guys? As I said, I mean, the formula for the sample variance and the sample SD should have n minus 1 in the bottom, not n, right? I know 2 or 3 weeks ago I had written it as n, but then I corrected it in the lectures, I think. Yeah, right? Okay, now the next thing is the histogram. It's the frequency table. Part 3. The frequency table is, I'm sure you've done this in A level. If you had done S1, S2, S3, you would know how to do this. We just have the interval, then the frequency, and then the density. So the interval goes from, because they're asking you to in widths of 5, so it's going to be like this. The first interval is from 25 to 30. Next interval from 30 to 35. Next into 35 to 40, 40 to 45, 45 to 50, and 50 to 55. So these are the intervals you will have, okay? The frequency is the number of data points falling in each interval. So if you count that, for this interval there is 1 data point, for this 2, for this 5, for this 8, for this 3, and for this 1. And all of this should add up to 20, because you have 20 data points in total. And the density is simply the frequency divided by the total number of data. So the density for this one will be 1 divided by 20, 2 divided by 20, 5 divided by 20, 8 divided by 20, and 3 divided by 20, and 1 divided by 20. And all of this should add up to 1. Because as you know, density must add up to 1, right? So this is known as the frequency table. It's just an interval, the frequencies, and then the density. Density is just simply the frequency divided by the total number. That's part 3. Now part 4. Part 4 of the question is to draw a histogram. Yeah. And I have, to make your life easier for you, right? To make the life easy for you, I have plotted the density versus the interval. So you will see, this is the histogram you will see. So this is the density, and these are the intervals, right? So you can see it's not entirely symmetric, but it's kind of skewed to that side, right? It's a little bit skewed to the left. Maybe it looks like it's skewed to the left. Yeah? Skewed. So it appears that the distribution is kind of skewed to the left-hand side, right? You get okay? Can you do question 5, please? Oh, no. What did I do? Can you do? You will not be able to do question 3 or 4 because I did not cover that material. But can you do question 5 now? Has everybody signed that and sheet? Anyway. And you guys do question 5, please. Yes. I will scan this and put it online so you can see, guys. And you do question 5, please, now. Anybody else? You guys sign that? You guys sign that?
I would have to So we look at the 80s and the 90s. We look at the say 18.
Do you think this is true?
So the main first grade.
Or so you're just
This how you can calculate
Anybody wants to hand
I got this quarter I got just hope you're not really going Oh, you can actually go forward with this.
Alright guys, listen please. So for the first part is again the 5-number summary. The smallest data point is 31. Our Q hat at 2.5. Your P is 0.25. Your N is 18. So N plus 1 times P is what? Is 19 divided by 4. It's gonna be 4.75, right? And the integer part of it is is 4. All right, so Q hat at 0.25 is you guys okay? Is 0.75. All right, and if you work this out, you will get 69.75. Is that what you got? Yes? Okay. Now Q hat, your P is half, right? Your N is 18, so your N plus will be what? It's 9.5, yeah? 9.5. So the integer part is 9. Alright, so you're listening to me guys. Right, so Q hat at 0.5 will be X with 9th smallest, 0.5. And if this, you will get the answer 78. Alright, and Q hat at the third part out. You guys done this or what? Yes? No? Your P is 0.75. Your N is 18. So N plus 1 times P is what do you get? Has somebody got a calculator? Can you 14.25? Alright, okay. So the integer part of it is 14. So Q hat come on guys, keep quiet please. Alright, and if you work this out, you will get the third quartile to be 87.25, right? And finally, the largest data point is 94. And you are also asked to work out IQR. Now, do you remember what IQR is? Now, how do you compute it? It's the difference between the third quartile and the first quartile. All right. So if you take the difference between these two, you will get the answer 17.5. So this is your IQR. All right. Right. Now part 2 is to draw the box plot. I'm sure all of you know how to draw a box plot, right? Oh, don't you? Let me show you how it looks like. If you draw it, it will look like this. See, I have drawn it. And the middle line, this middle line is the median. Alright, this line here is the third quartile, so it's Q at 0.75, and this line here is the first quartile, which is Q at 0.25. Right? Now, how do you do how do you draw the outer viscous? Do you remember that? I explained this in the lectures, guys. What is the distance between? What's the distance from this point to this point? It's 1.5 IQR. You remember that? I told this. So you take the distance between these two is 1.5 IQR. But you forgot already about. And similarly, the distance between these two is 1.5 IQR. Right? So you just measure. We have already computed the IQR. So you just multiply that by 1.5 and measure the distance up to this. Right, and similarly, measure the distance up to this. Right. All right, that's how you get. Is that clear, guys, or not? Anybody who's not clear about the box plot? Hello, guys. So all you have to do now is the median, the first quartile, the third quartile, and the IQR. If you know those four numbers, you should be able to draw a box plot. And then this is how it should look like. Okay? Alright, that's part 2. Now part 3. Part 3 is part 3 is part 3 of the same question. Is to compute the x bar and the s and the median. Right, and for this data, x bar is equal to 75.06, s is 16.540, and the median is 78. So what can you tell about the distribution? The mean is 75.06 and the median is 78. Now, if a distribution is symmetric, then you would expect right, for a symmetric distribution, the mean and the median must be equal. Now, in this case, since in this case the sample mean is less than the median, so the distribution the distribution is skewed. It's actually skewed to the left, right? Because if you look at the box plot, the tail on the left-hand side is longer. So the distribution of the data is skewed to the left. All right, can you do question 6, please, now? Question 6. Alright guys, are you doing question 6 now? Right. Yeah. Okay, now this guy here, because of the property I mentioned in the lectures some time ago, what distribution will this have? This will have the standard normal distribution. Right? So this is equal to phi. Right here, phi denotes the right? So that's how you do part 1. Part 2, so this is part 1 guys. Okay, part 2 is to find the quantile. Remember this morning I told you how to find the quantile. To find the quantile of a distribution, right? All you have to do is set the CDF equal to P and solve for X in terms of P. So this implies right, and this implies so right. So this is the quantile. So Q at P is equal to mu plus sigma times sigma inverse of P. Just a minute, guys. Just give me one minute. Now, finally, to find the IQR, remember IQR is the difference between Q at 0.75 and Q at 0.25, right? So this is gonna be mu plus sigma right, the two mu cancels, so what you get is sigma times right. Alright, now if you read these two numbers from the table, I mean, I gave you tables for the normal distribution, at least I talked about it, right? If you read these from the table for the normal distribution, you will get this to be equal to 1.349 times 6. Alright, that's question 6, guys. If you have done page number 4, can you give it to me now, please? Or you can give it to me tomorrow if you haven't done it.
I need to know.
Hello. No, that's the inverse function. Inverse function. That's the inverse function. If you take the inverse function both sides, this becomes phi inverse. So this is the inverse function. Inverse function of phi.
But that is seen to this, the inverse function. No, the inverse function is seen as this.
Yeah, you apply the inverse function both sides. So this becomes this, and right. Thank you, sir. You apply the inverse function to both sides. So this becomes this, and this becomes phi inverse at P.
What is this inverse function?
I mean, that's how it works. Like if you do an inverse of, like if you do a phi inverse of phi of anything, it's simply equal to this. You know what I'm saying? So if you apply the inverse function to both sides, whatever you have here is what you get here. Yeah. Hello, sir. Oh, okay, good. Have a good weekend, man. Have a good weekend.
And you.
Yeah. Have a good weekend, guys. You can come and see me in my room if you need more help. Okay. Hello. We are in the other room, not this room. Oh, you have a class here? We are in 107. No, it's everything is like that. It's in 107. Wow. 207.